Welcome, my friends. Recall that the slope of a line measures how steep that line is. There are four different possibilities. A line that moves upward from left to right has a positive slope. A line that moves downward from left to right has a negative slope. A horizontal line has no steepness and therefore has a slope of 0. We classify a vertical line as having an undefined slope. In this video, we will focus on the last two cases, the horizontal and vertical lines. The equation of a horizontal line is always y equals b, where b is a constant. B also happens to be the y-intercept, just as it was in the slope-intercept form of a line. For example, the equation y equals 3 creates a horizontal line at y equals 3. The equation tells us that y is equal to 3, but x is not specified. That means for every possible value of x, y must equal 3, which creates a horizontal line. Horizontal lines have no steepness, so the slope of a horizontal line will always be 0. The equation for a vertical line is always x equals a, where a is a constant. For example, the equation x equals 1 creates a vertical line at x equals 1. The equation tells us that x is equal to 1, but y is not specified. That means for every possible value for y, x must be equal to 1, which creates a vertical line. Vertical lines are classified as having an undefined slope. A vertical line does not run horizontally, meaning it does not increase as we move from left to right, which is the reason we do not classify vertical lines as having a slope. Also, if we apply the slope formula to 2 points on a vertical line, we will get the divide by 0 error, as we will see here shortly. The main thing to remember is that the equation y equals a constant is a horizontal line with a slope of 0, and the equation x equals a constant is a vertical line with an undefined slope. Recall that the formula to calculate slope given 2 points is y2 minus y1 over x2 minus x1, and that we label slope with the letter m. Let's try a few examples of using the slope formula for vertical or horizontal lines. Consider the line connected by the points -3, -2, and 4, -2. Let's find the slope of this line using the formula. I like to let the first point given represent point number 1, and let the second point given represent point number 2 in most cases, although it doesn't really matter if you want to switch them around. That would mean x1 is -3, y1 is -2, x2 is 4, and y2 is -2. Plugging into the formula, we have m is equal to -2 minus -2 divided by 4 minus -3. Make sure you include the parentheses as we are subtracting a negative number, both on the numerator and denominator. Simplifying, we get m is equal to -2 plus 2 over 4 plus 3, which is 0 over 7, or just 0. The slope of the line passing through these 2 points is 0. Do you remember which type of line has a slope of 0? Horizontal lines have a slope of 0, so that means that the line connected by these 2 points must be a horizontal line. Let's try one more. What is the slope of the line passing through the points 2, 5, and 2, 1? We can let x1 equal 2, y1 equal 5, x2 equals 2, and y2 equal 1. Plugging into the formula, we have m is equal to 1 minus 5 over 2 minus 2, which simplifies to -4 divided by 0. Division by 0 is not defined in math, meaning that our slope is undefined. Vertical lines have an undefined slope, meaning that the line connected by these 2 points must be a vertical line. Alright, my friends, that completes our video covering horizontal and vertical lines.